Well, hi everybody. I'm here today to talk to you about Polywrap. I hope you're excited. I hope you're ready. The main purpose of this project is to try and bring Web3 protocols to all types of applications. And so we'll talk a bit about what that exactly means in a sec. First off, this is who I am. I'm Jordan Ellis, just so there's a little bit of information about who's talking to you today. I spent the beginning of my career working on game engines and also operating systems, and that was really fun. But once the Web3 bug kind of hit me, I jumped into that space about 2 years ago. I've been working at the dApp development shop ever since then, and also out of that we spun out Polywrap into its own project. And so that's what I've been spending my time on for the past 6 months to a year. And the reason for Polywrap is the fact that over the past 2 years at dApp, we've worked with lots of different clients. And we've seen the same problem pop up within all of these different Web3 projects. And so that problem is the Web3 integration problem. And so I'll talk to you today about what exactly is the Web3 integration problem. So this is Web3 today. We have lots of JavaScript SDKs. The reason for this is because for Web3, we don't want a central server to be authoritative. So we don't want that central server to be acting on our behalf. We want to be taking as many actions as we can inside of the application, since that's where our private key lives. That's where our domain lives, where we know what's going on inside of our device, or at least we think we do. And so we have lots of JavaScript SDKs. There's lots of problems with this, though. And so what are these problems? One, JavaScript SDKs are not multi-platform. If you wanted to bring a JavaScript SDK into another language environment, like let's say a game written in C++, because that's my personal background, to bring the JavaScript virtual machine into another application, it's extremely heavy. And so JavaScript is not portable. And so that's a big downside. A lot of this code would have to be rewritten in another language to be usable. Also, JavaScript is insecure. And so there's been lots of different exploits that have happened in the past where a single JavaScript package has kind of exploited a whole application, which I'll go into more detail in a second. And then the last two, it's not scalable, meaning that the more JavaScript SDKs you add to your application, the larger your application grows, and so your bundle size grows. And so what ends up happening is if you look at the DeFi aggregator applications out there, a lot of them are using centralized servers right now to do their aggregation. And it's because they're doing lots of data processing, but also because to introduce new protocols, it bloats the app. And then lastly, it's not standardized. So each JavaScript SDK is written differently. And so I'm sure that you've probably spent hours going over, let's say, like IPFS's JavaScript SDK or Ethereum's or some other project like let's say Uniswap, and trying to figure out how exactly to construct the objects, use the functions, what interfaces and what call patterns are the right ones. And each one's different because there's lots of different ways to architect your JavaScript, object-oriented or functional or other things like that. So I propose to you today that Polywrap is a solution to all this headache. And so I'll walk through some examples, show you the main solutions that we're presenting and how they actually work under the hood. And we're going to get into the details, and please, let's get as deep as you guys want. So first off, with not being multi-platform. So this is kind of like the JavaScript paradigm here. In order to bring your JavaScript code into other types of applications, you would have to rewrite a lot of it in different languages that are geared towards what you're trying to do. So let's say a backend service in C# or a mobile app in Java or a iWatch app in Swift. And so you'd have to rewrite the same SDK for, let's say, Uniswap in all these different languages to use it inside of your application. But with Polywrap, that's different. We can use Polywrap in all of these devices, all these different types of application environments, without having to rewrite your SDK. So it's a single SDK that can go everywhere. Magic. I'll talk about how we do it in a sec, but we use WebAssembly. That's the main. So anyway, this is the insecure case. So, we've probably read articles in the past where, let's say, some kind of crappy Bitcoin wallet that lots of people were using got hacked because a single JavaScript package was able to go and get a private key and send it off to a server where they drain the wallets. You know, in Ethereum, we use MetaMask, a browser extension, so we think we're beyond this. But in reality, if there's a browser update that gets released tomorrow that leaves your browser extensions vulnerable to some kind of like, you know, switchery within JavaScript, any module, like, and I mean any module in your node modules folder of thousands of them, could actually go through your application, access the window, you know, do naughty things. And so in the world of Polywrap, each polywrapper is isolated inside of its own sandbox. And so this fixes that. It can't actually access your application memory directly. And so if you were using, let's say, a private key inside of your JavaScript, which is very, very bad, don't do that. But if you were, you wouldn't have to worry about the polywrappers that you were executing because they can't actually access your application memory directly. And so that's cool. And then on the not scalable point, so if you build an application with lots of JavaScript SDKs, performance degrades, load time degrades, you know, a lot of stuff. And then with Polywrapper, what we do is we pull down all of the wrappers that we need, and we get rid of the ones that we don't. And so this allows you to basically add an infinite number of integrations into your application, and the garbage collector will basically get rid of the modules that it doesn't need, and you can tell it, hey, keep my runtime heap size to like, you know, 5 megabytes. And so it'll basically make sure that it only keeps on hand the polywrappers that it's using, and that keeps it underneath that threshold. And so this is very similar to the Web 2 world, where you can add an infinite number of Web 2 requests to your application without bloating your application. It's the same kind of thing here. And then with JavaScript, it's not standardized. So like I was saying earlier, all these different SDKs are written differently. So trying to compose them in different ways, like let's say you wanted to use Compound's JavaScript SDK with maybe Uniswap and also with Aragon's or something like that. They're all written very differently. So composing them would be a lot of hand stitching and a lot of headache. But in Polywrap, what we do is we use a standard way to define interfaces of your modules. And so composing them actually becomes very simple because they all have a similar interface. You can also define standard interfaces similar to, let's say, smart contract standards. And so, you know, composability, being able to have on-demand kind of like extendability is really interesting and cool. And so we'll actually get into the details of how we do this. But before we do that, here's kind of our blow-by-blow. You know, why is JavaScript way better or way worse than Polywrap? You know, we really want to move the Web3 space forward, and we believe that getting away from JavaScript SDKs is a huge step for that. Just a quick anecdote. I used to work at Microsoft on like enterprise blockchain stuff. Wasn't the best thing. That's why I left. But you know, a key tidbit from that experience is that we rewrote everything in the JavaScript world that like mainstream Ethereum world was using today. We wrote a lot of stuff just rewriting it in C#. And so like the rewriting happens. It really does. For instance, we've talked to lots of launch partners, and I'll talk about that in the future. But anyway, yeah, I'm just trying to tell you, JavaScript's not the way, man. All right, so how does Polywrap work? Let's get into the details. This is the fun stuff. So first off, we use WebAssembly. And so this is like our major cornerstone that allows us to actually do this. WebAssembly allows us to be usable everywhere. It's a very lightweight bytecode standard that has implementations for running it in every major language. And so from everything from like a, you know, small IoT device that's memory constrained to, let's say, like a backend server written in C# or something like that, or Go or Rust. And additionally, WebAssembly is sandboxed by default. So these WebAssembly modules, they can't access the host environment. You know, like they're operating in a little isolated container. And so this gives you that great property of being, you know, shielded from whatever it may do. Decentralized storage. So this is another big part. How do we actually fetch these Polywrap modules on demand, like I was telling you earlier, to give you that kind of infinite composability? We use decentralized storage. Here I'll show you an example using IPFS, but we do support any decentralized storage solutions. And so we'll talk about IPFS here first. And so infinite scalability, how we do this is we fetch our modules from IPFS, we download them into the app. They're very lightweight. We recently rewrote the Uniswap JavaScript SDK in a Polywrapper, And the query module and the mutation module, it's like 200 kilobytes or something like that. And so just really, really quick to download. And then we get rid of the ones that we don't need. And so with this, we can keep our memory space low. We can keep the app running smoothly. And then since we're using IPFS and it's all hash addressed, we can make sure that we're downloading the same content each time, which is really handy. And then lastly, we use GraphQL. So this is our interface definition language. We use kind of a little modified version of GraphQL, but it allows you to define simple interfaces for your polywrappers. And so this way, you can compose them on top of each other. This one could be used in this one, and this could be used in this one. And then additionally, you can define standard interfaces with your GraphQL. And so I'll show you kind of an example that we can talk about in a little bit. So these are kind of the three main pillars. We have the execution, which is portable WebAssembly. We have the storage, which is decentralized storage, and also content address storage, which is really important. And then lastly, we have our public interface, which is GraphQL. This is like our semantic interface to our runtime code. So ready to get started? Let's talk about how we do this. And really quickly to the person in the back doing sound, could you let me know when we have like 5-10 minutes left? Yeah? Okay, cool. Thank you. So the first step is you need to add the Polywrap client to your application to run Polywrap modules. And so it's no different than, let's say, adding an HTTP client to your application to run HTTP requests. Here we're adding the Polywrap client to our JavaScript application. And then once it's installed, you simply start the client by just importing it and creating it. A quick note, when you create your client, this is where you'll basically add any host capabilities that you want to add to your Polywrap client. So for example, if you had like a private key for Ethereum's signatures, in MetaMask, you would add your MetaMask provider here to be able to support those types of signatures that are happening inside the host environment and not in the module. And then lastly, we can query something. So here we have an example where we do client.query. We do ens/uniswap.eth. And so at this ENS address, it'll redirect to an IPFS hash, and then we'll download the polywrapper there. So ENS IPFS content. And then here we just send a query to the module, and we say we want to do a swap mutation. So this is a write operation. And so what this will do is the client will go out. It will go ahead and fetch the polywrapper using the resolution process. It'll then go ahead and execute the swap function with these arguments. And boom, like you're using Uniswap right in your application. No need to install the Uniswap SDK. You can just query it on demand. And any protocol is just a request away. So that's kind of cool. Kind of cool. And so here, let's go and look at what the build experience looks like for actually building a polywrapper. And so here we define the schema. So this is a query module. So these are reading operations. We have a function called method with an argument. And then we can also define custom types. And over on the right-hand side, we have to implement our WebAssembly code. And so first off, this code that you're seeing is assembly script. But don't worry, we're not only supporting assembly script. We've actually built a toolchain so that we can support any language that compiles down to WebAssembly. And so the next language we're adding support for is Rust. And so here we're showing you, this assembly script example. In the future, we'll also have Rust-based examples for building polywraps. We have this method. As you can see here, we are importing our custom type and also our input variables for the method. And then lastly, we have our business logic here. And so this is obviously a very simple example. If you wanted to see some more interesting demos, I'll give you links at the end. But yeah, let's move on. So the next step is composing polywrappers. So you can actually import a polywrapper into your own and query it, just like the application was before. And so here within our schema, we do a little import statement. We say import the query type into API, so this is a namespace, from ens/api.domain.eth. So this ENS address points to a polywrapper, and the toolchain will actually go out and fetch that schema and add it into your WebAssembly code and say, hey, you're trying to query this polywrapper. Let's go ahead and add that to your generated code that we do for you that lives in this little W3 folder here, which this has to be renamed because that's from the old branding. We used to be called Web3 API, now we're called Polywrapper, so this will get renamed. And yeah, the auto-generated code will go ahead and add the, the nice function for you to call, so it looks like you're just calling a normal function in your code. But what's actually happening when you run this is it's sending out a query. It's sending out a query to that endpoint saying, hey, execute this, and the client will resolve that. So this is really nice. You can have composability. You can import other polywrappers into your own. And then in addition to this, I just want to touch on the fact that you can also define standard interfaces. And so we could basically say that, this query type is an interface, and we could implement that in our module. And then you could imagine in the future, maybe there's some on-chain registry of implementations. So it's like you look for, let's say, all the implementations of the automated market maker Polywrap standard, and then building DeFi aggregators is really simple. Other things like that is really interesting to think about. So these are our launch partners. So the cool part about our launch partners is that we talk with them about their issues. And if Polywrap solves some of their issues, we say, hey, become an early adopter, become a launch partner. We will talk to you regularly. We will give you tours of what the toolchain looks like, grab your feedback so that we know that we're actually providing usefulness to your use case. And then we're working with them now. We're getting to the point where we're actually starting to get slots on their roadmap to build out their initial polywrappers, which is really exciting. And so these use cases are all very interesting. I'm not going to talk about all of them because I don't know what all I can talk about, but just to know all those different features of Polywrap, each one of these launch partners has a different niche use case that really requires that. And so it's very cool that we've gathered kind of like a broad set of users. And these users are going to be the first ones available on the hub. And so the Polywrap hub is basically going to be a place where you can discover discover any Polywrap you want. So for example, you could type in multisig and you would get like 5 different examples or 5 different polywrappers, maybe on different chains of a multisig Polywrap. And you can deploy it. So if you're building something, you can go here to easily deploy and make sure it stays online. And then lastly, interact. So right inside of the hub, you can write and read from any of these polywrappers, which is really exciting. And so here we have a quick example. This is a little sneak peek. We're using the Uniswap v2 polywrapper. We're sending a mutation query with a swap. And then here, as you can see, this is the successful transaction receipt with the hash and all that fun stuff. So, it's really working. It's really doing. If you want to test it for yourself, we have a demo. This is the Uniswap v2 demo where we forked their interface and we went ahead and kind of, we took out all of the JavaScript SDK and we put in the polywrapper that we built. And so it was a really great stress test for our system to make sure that it actually functions at production. And so if you want to check this out, just go to this URI. And over here is the normal swapping interface. And over here, you'll see the actual queries that get executed to execute a swap. So yeah, thank you so much for listening. I would love to spend some time on questions. Quick call to action. Follow us on social media if you want to stay in touch. The slides are available right here, so if you were stressing taking pictures, just go ahead and scan the slides. You can get them later. We have docs out, so please come and use it, provide feedback, join the Discord. We actually are operating as a DAO, and so we like to incentivize community growth, and so we have done things in the past where we incentivize people to give reviews on the documentation. I'm sure we'll do more of that in the future. Try and integrate it into your things, and if you'd like to join the project, because like I was saying, we are a growing community, join. We have funds. We pay developers. I think we've paid developers, I think it's $500,000 so far, which is really cool over the past 6 months. And so we're really pushing it out there to lots of different devs. We're looking to grow. So if you want to join us, come and join us. It's really fun. And yeah, that's Polywrap. Thank you. If we have time for questions, I'd love to talk about some things. Who has questions? Yes.
First of all, amazing project. I love it. There's a lot of protocols, a lot of versions of different protocols, SDKs that have errors that get propagated through versions. How large is your dev force to be able to be up to date with all of that?
Yeah, so not at all. But the idea is to build a tool chain that can help protect against those very things you talked about. So for example, the concept of versioning and having breaking changes, what we're doing in order to solve that is we're building a better version of NPM, where we're actually building a smart contract to be in, think of it as like a smart contract based NPM, right? Where you can actually anchor specific versions, and you're guaranteed that that version will never change. And then through different semver, like granularity. So it's like maybe you leave out the patch, but you have major and minor. What that says is it says, all right, I'm opting into patches, which means that the WebAssembly code can change, but the schema will never change. So I'll never hit a place where I try calling something and it says, oh, my schema changed. That function doesn't look like that anymore.
You mean the schema of the function call?
Yes, right.
Okay. Yeah.
And so, yeah, there's different granularities in which we can make the version registry useful. And that can allow you to further lock down your dependencies. And then additionally, we want to build the feature where you can just run a build command for your polywrapper and say --lock. And it just iterates through all of your dependencies, and it grabs the specific like static content identifier for all of them. And so that way you can guarantee that nothing will ever change. It'll always execute the same way. So yeah.
Amazing.
Yeah. Looks like time's up. Thank you for the question. That was great. I really appreciate your time. And yeah, thank you.